Hi guys, welcome to video 2. We're just finishing up the first page of lesson 1. You should have your chart filled in. You can check your numbers there as I'm talking. Essentially what we did is we took our lower interval for the first 2 seconds, well, that's one we did together, and then we did the same thing, found the lower, the middle, the upper for all of them. There's some cool patterns in there, noticing that the upper and lower, upper and lower, upper and lower are always the same, moving from one interval to the other, which makes sense since they're based off the same point. And I add them all up to get my total of 274, 324, and 299. Okay, so what we did is for a lower estimate, we always went to the lower point and we drew our 2-second rectangle, found that area. Drew our 2-second rectangle, found that area. Drew our 2-second rectangle, found that. So we are stacking up these rectangles and we're finding a low estimate underneath that curve. Or we could also stack them up and find a high estimate. Or we could try and find that middle and find a midpoint estimate. What we can now say, now that we've done all of this, is that over that 12-second interval, the distance traveled was at least more than 274, but it was less than 324. Maybe a good midpoint would be 299, but at the very least it has to be between 274 and 324. Okay? And that would be why we found those rectangles. We were able to find an upper and a lower limit. Okay? Okay, and we're moving on to question 5. Use the data plotted in question 1. Construct rectangles that represent each estimate of distance using the same scales. So I've already plotted these points. I'm using the same speed scale for all 3 of these different plots. Time, time, and time. They're all going to be the same. Here, this is going to be my lower estimate. Here, this is going to be my higher or upper bound estimate. Okay, lower, upper, and then we're also going to talk about the midpoint. So I already kind of showed this over here with my rectangles, but all we're going to do is we're going to say it was this rectangle, it was the lower one, always starting at the low point to build my rectangle for each of these points. Okay, start at the lower rectangle and build. And my lines are not perfect, but I think they get the point across. I'm finding that area. It's a lower estimate. I can do the same thing with my upper estimate. So what I'm doing is I'm starting at my upper point, and instead we're kind of working backwards this time. Okay, upper estimate. And you'll notice that these rectangles are all taller. And since they're the same width, these are all going to have higher area. So if I go to the upper estimate, well, I'm going a little bit above these points every time. So my estimate is going to be higher. And that makes sense. That's what we got. Our lower estimate was lower, our upper estimate was higher. And I can do the same thing for my midpoint. I'm going to go ahead and plot these middle points here, and I'm going to draw in all those rectangles. Okay, this, I'm a little bit above at times, but I'm also a little bit below my plotted points. So maybe it would all balance out, and for every time I was above, I was below the same amount. For every time I was below, I was also above. Well, I would have to get pretty lucky for that to happen. So hopefully we find a more accurate way to do this. But that's what I'm doing. Draw a smooth curve through the data points and explain how the total distance is related to that curve. Okay, well, I've already done that. We've already talked about how that could be a general curve. Well, the distance was what we found with all of these areas. It is the area under the curve. And if I was to add up all of these intervals, it would be the sum of the intervals. Okay. If I wanted to improve my estimate of distance traveled, one thing I could do, okay, is have smaller intervals so I don't have as big of gaps between them. And this is something we'll talk about, or that would come from having more intervals. The more intervals I have, okay, the more tightly packed they're going to be, the better my estimate is going to be. Okay. In general, we can find average speed by dividing the total distance by the total time. Use your results from question 3 to obtain upper and lower midpoint estimates for average speed. So my upper was 324. divided by 12. I'll find that number. My lower estimate was 274. Okay, I'll divide that by 12. And my midpoint was 299. I'll also divide that by 12. Okay, I'll leave that for you guys to do. You can find the decimal, and that would be your average if that was the actual distance traveled, upper, lower, or midpoint. Okay, we're going to move on to definitions. I'm going to start that in the next video.